Hello everyone, this is training an AutoML community call on 27th of November. This meeting will be recorded and published on YouTube. This meeting is governed by the Kubeflow Code of Conduct. Welcome everyone. So do you have any new people here on the call who just to introduce themselves? Just want to say hello to the community.
Hey, I'm Valentina. I'm a principal architect at Red Hat. I'm part of the release team as well. And yeah, I'm here to listen, to learn, and get to know you. So thank you. Thank you so much for doing this.
Nice to meet you, Valentina. Thanks for joining.
Of course.
Anyone else want to say hello before we can get started? All right, sounds good. So in that case, let me just share my screen so we can go quickly through like the agenda items. So I think before we jump to this discussion around LLM trainer that Xiao is going to talk about, I just want to give you a quick update on what we have right now for the V2 work. I think we've done a very good progress so far. We kind of presented this talk in the latest KubeCon together with Yuki. I think it was great. Unfortunately, I wasn't able to attend this event in person, but Yuki has a lot of good conversation with different folks, especially for people who just want to get involved. And I think we have a lot of potential in terms of all those blueprints and how we streamline the fine-tuning process on top of Kubernetes. So I think this is great. We have few interesting discussions around how to make it easier for everyone to fine-tune the latest LLMs using all this infrastructure, and in the same time maybe even provide a sandbox environment for folks to play with. So this demo actually includes two simple examples. So the one example, actually the development of the PyTorch model, when I showcase how actually data scientists can, have their notebooks and Python files sitting together so they can quickly develop their PyTorch code and then distribute it across multiple machines. And the second example was about like the Llama 3.2 fine-tuning the Llama, I think just one BL parameters, not very large, but just to show how easy it is to perform these fine-tuning tasks. So please take a look at the talk. I think it's interesting. I think we have a few things that we need to work on in terms of deliverables and have MVP being released. So I guess one thing that we need to talk about when we actually planning to make a release. So the goal was to release 1.9 of training operator in December. And when we release the 1.9, we're also planning to release MVP of 2.0. So we can be focusing on the 2.0 work and at the same time maintaining the latest release of training operator. So I guess like my only question is to the community, do we have any like pending PRs or pending issues you want to see in the V1 from us, from the maintainers? I think there are a couple of pending PRs, but any like any pending PRs from your side you think we need to tackle with?
Sorry, Andre,
Yeah, go
who are
ahead.
you asking the question?
I think it's like in general like the community.
Oh,
So if you think we're kind of missing something in the bot, because our goal was to release 1.9 in the release branch, and then only focusing on the 2.0, and at the same time maintain the stable version of 1.9 for like maybe a year and a half, so all the customers can migrate
got
smoothly.
it.
Just like want to know from the community, is there any kind of pending PRs that's maybe pending like issues in the V1 version of training operator that you want us to address before we actually make the release? Yes, I know there is some work to migrate to Kubernetes 1.31 and 1.30. I think we already migrated to 1.30, but 31 is still in progress. Also, like we want to support a customized V5, and I guess there is some PRs to implement the test for the Python notebooks using Paper Mill. I don't know if there's any, I guess the question is like, if there are any kind of bugs, we can always, propagate them to the release branch directly. But just want to know more about like if there are any specific features which are missing. Um, yeah, so in any case, I guess let me sync with Yuki and Jono and Yuan offline, and then we can maybe release something by maybe mid of December. Um, yeah, because we need to see like if you have any significant bugs, because I saw some issues have been created recently, but I don't know if they're actually related to the V1 work. Yeah, go ahead, Valentina.
Yeah, so in terms of for me to try to learn more about it, the release as a whole, and also this module, what do you think are the most like important features that you are planning to release?
Yeah, so we have this 1.9 roadmap.
Yep.
Um, I think this is not all of them. So I think like first of all, in 1.9 we support JAX, and also I guess we maybe I can make a point here. We also support multi-queue with queue. So this is the
Nice.
API that has been contributed by some folks from the batch working group. Um, we make it support multi-queue. Yeah, so this feature was contributed several weeks ago, and we updated the API, which actually introduces manage by parameter. Yeah, but supporting JAX, I think like one of the features that probably many actually users want to get right. Um, yeah, so I guess there will be kind of support to manage. Yeah, I think I can remove this part from here. So this is our tracking PR. Yeah, tracking the issue for 1.9 release. I guess we also have this roadmap issue for 2024, but it's general for training operator.
Yeah, I've been asking everyone because yeah, sometimes on the issues you have like 10, 20 issues, and sometimes some of them they will be there or not, and just to have like the high level view. But I think that you listed and just wanted to make sure is that was kind of up to date. So thank you.
Yeah, there are probably more, like I need to review all the PRs who've been committed to the 1.9.
Mm,
Yeah, but this is the tracking release, which I will update once we release the 1.9 of training operator.
good.
I think our goal was to release 1.9 because we want to update the README and we want to remove the legacy 1.9 code from the master branch. So
Mm,
focus on, on the 2.0 work. But at the same time, I understand, like, because many customers are still in the existing version of training operator, so it will
mm.
it will take time for them to migrate, right? So
Yeah, yeah. No, thank you. And
mhm.
Andre, are you I guess you're always looking for help, but do you have like the first issues or things like I think my idea will be to try to contribute to each module from now on and find some
Mhm.
time on my own to do that. But yeah, is that something do you need any help with anything for the release or
Yeah, absolutely. I guess like we have a lot of, the good first issues, and also at the same time it depends like whether you want to, help us with the documentation or want to help us with some, backend updates there. So on the terms of like the work, well, do you know like exactly what you want to work for, or in general you just want to see what is a small, low-hanging fruits you can take and, start to contribute?
Yeah, I lately been working on the website, but I want to. I was yeah. Right now I'm an architect, so I'm more like building demos, workshops. But I was a developer a long time ago, well, like 5 years
Hmm.
ago, working
Yeah.
Java, mostly backend. So I can do code like backend,
Hmm.
but maybe start small. Start like setting up the local environment and maybe do some small things that I can, just help me start learning as well about the module.
Yeah, absolutely. So we try to mark a lot of good first issues for contributors. I think it's this one. So I think like for 2.0 work, there definitely will be more once we kind of have initial version of SDK and also initial version of, so we're already supporting the PyTorch distributed, but with all this discussion around like LLMs and these trainers, there will be small tasks you can also take. There's also a big task about docs for V2. And I also like, I want to get some help from the community for this because we want to see how we can, construct these docs in a way that will be useful for many user personas, especially like how right now we kind of delegate the CRDs for different personas like data scientists and DevOps engineers and MLOps engineers. So we should we should actually construct our docs in a way that every user can benefit. Like, data scientists then see their own specific docs. Platform engineers, they also like gonna see the docs, how they can modify these runtimes. Yeah, so there will be definitely a lot of things we can improve from the documentation perspective there. Um, yeah, but take a look at this, good first issues. For the docs again, if you want to help us, I can, we can maybe start.
Yeah,
For
I can
instance,
start with the docs if you need help on that.
yeah,
Yeah.
yeah, absolutely. And let me also connect you with some folks here so they also can help. So maybe we can see how we can collaborate together on actually creating these docs for V2.
Yeah.
Um, yeah, it makes sense. Because there also,
Perfect.
yeah, good.
Hi, Bubba.
We also need to have a migration document for customers from V1 to V2 because it is a breaking change from the API perspective.
Great. I think Francisco was about to say
Yeah, Francisco,
something.
do you want to say something? Or
Nope, I'm sorry.
okay.
I thought I was on mute and then my daughter came by. That's her head right there.
Yeah, no worries.
Sorry about that.
Oh, good. Thank you, Andre. Thank you.
Yeah, sure, no problem. And again, like we will create more good first issues soon, because we just want to basically have a scaffolding and like all this initial implementation, because there will be a lot of more kind of small tasks people can help with V2. I know we already have some some contributions from the community, especially from the unit testing, and other things around validations, PRs that's we're reviewing. All right, so any other questions for V2 work before we jump to this discussion around LLM trainers?
Yeah, one small question. So, the manifest for V2, would they be over for the release timeline of 1.10?
Yeah, I think so. I think they're already ready, right? So we already have this manifest.
Yeah,
Um,
yeah.
I think the question how we want to include them in the Kubeflow manifest, right?
Hmm.
Um, so this thing we need to probably get help from the community, right? So I think we need to create a manifest for the Kubeflow installation. Yeah, I don't know if it will be like a lot of differences. So the only difference that we have right now that we don't use Cert Manager.
Hmm.
So we also need to install the job set controller.
Right.
So right now, like the job set is actually like we're importing manifest from their upstream 0.6 manifest.
Got it.
Yeah, I think we need to probably Julius help, and I don't know if what is actually our plan there. Yeah, but definitely we need to someone who can help us to synchronize those manifests, right? I can create a recognition actually for this.
Sure.
Also, I guess one thing that we're working on, it's for the job sets. So we try to update the startup policy API. Not startup policy API, we actually try to support a serial job execution. So this is actually allows us to create the sequence of the jobs. And especially it is useful for LLM runtimes when you do the initialization on CPU and then training on GPU. So if you're interested, take a look in this cap. We try to see what is the ideal API experience on the job set side. Yeah, but this is the first thing we want to contribute to Kubernetes directly, so we can improve the train job creation, and ability to orchestrate more kind of complex sequence of the jobs, especially on this fine-tuning runtime. So if you're interested, take a look on this. I think there will be more features from the job set side, as we discussed, like, Elastic jobs, Elastic support. Also, there will be like the stateful job sets, like to orchestrate volumes and other things. So I think there will be we have a lot of opportunities to contribute directly to Kubernetes and to the Kubeflow as well, because we kind of right now rely on the Kubernetes upstream components. So if you're interested, let me know. Yeah, I can definitely, guide you how you can contribute directly to Kube, especially on this V2 work. All right, so any other questions before we move on to discussion around LM trainers?
I was wondering, like, how will V1 continue to be supported once V2 is rolled out? Like, what's kind of the plan there?
Yeah, I think like we discussed this before. So let me ask you, do you use this V1 in production?
No, I don't. I'm just curious.
And did you use any of the Kubeflow components before? Or you just tried to explore?
No, I haven't. I've started to explore.
Okay. Yeah, I think V1 will be supported for at least a year and a half. Depends on the customer's migration.
I see. It makes sense.
So probably it won't be a lot of significant features to be contributed. But like if we see a need, for example, integration with queue, like multi-queue, right? So we're already supporting like managed by API, which allows us to actually orchestrate, training jobs across multiple clusters. That actually, I think this feature will be supported by the community, so people can leverage Q with K on, with all those capabilities, right? And especially in this KubeCon, Q was the one of the biggest topics. I think many organizations, they see the needs of managing those advanced workloads on the large scale Kubernetes clusters. So we definitely have like, strong relationship with all this batch working group components. Yeah, but I think like the main goal for us, again, to consolidate effort between batch and training working group. So we provide unified infrastructure and we deduplicate effort. So for example, like, supporting new runtimes or supporting like Elastic capabilities, there is no need for us to contribute this to our controller. You have this, unified controller and the Kubernetes jobs directly, right? Yeah, so
Yep. Makes sense. I think there are a lot of other issues for V1. I think they're all going to be what's going to happen there. Like,
I'm wondering for which kind of issues specifically you're talking about. Can you give me an example?
I think that there are a lot of other issues. I think specifically for V1, as we're migrating to V2, like what's going to happen to them in general. I mean, nothing specific, but
Yeah, that's why like I'm asking, like, what is there specific needs you see or problems? I know there is some issues like the feature requests from the, what is it, exit codes on like, to improve the node disruption and improve the training fault tolerance. So basically you can you can restart the jobs, right? And you can make sure you actually won't fail the whole job in case of failure, right? So do you have any specific feature requests in mind that we can talk about?
nothing specific. If there's anything, I'll let you know in the next call.
Yeah. And we can also start the threads and discuss
Yeah.
this. But we can, if it is actually required from any customers, who can definitely, contribute it to the 1.9. Because as I said, like 1.9 will be supported for like, a year and a half or maybe more if we see all the demand from the users. Yeah, but
I see.
ideally, we want to migrate all the customers.
Yep.
All right. Any other questions? All right, sounds good. So in that case, Shao, do you want to share your screen so we can discuss your proposal?
Yeah. Can you hear me?
Yeah, we can hear you.
Yeah. I want to share my screen to share the doc. Let me share my screen. Can you see my screen?
Yep.
Yeah. First I want to discuss about the Kubeflow training v2 LM trainer design. It's a part of Kubeflow training version 2. If you haven't heard of this, you can check this document for reference. It's about training v2, and you can get some basic ideas, basic concepts like running time and change job. Here, if you are puzzled about it, we decided to implement a custom trainer to fine-tune LLMs. And you may ask, what is a trainer? I once think about it, and especially when I haven't read the training version 2. Let me use a picture to introduce it to you. This picture comes from the slides of Andrew and Yuki's talk in Kubeflow North America. And what is the trainer? You may see that. When we training the model, we need models, data sets, and the training scripts. We will have a storage initializer cleaner to download the data set and the model to the PVC, and this downloads the models and the data sets. And another one is the training scripts. You can understand the training script as a trainer. This is what we use to fine-tune the LLMs and export it to the cloud storage. Yeah. This is a basic idea of trainer. And what the benefits we'll get from the LLM trainer? We will support it officially while training runtimes in Kubeflow upstream. And I think this will ease the workload of writing fine-tuning scripts for MLOps engineers, since they can just use this scanner. And when it comes to the data scientists, it will provide an inbox toolkit to fine-tune the LLMs, because they just use the Python SDK and they don't need to modify the YAML file. A very low YAML file is not familiar with the data scientists. And I think the LLM trainer should support these features in the long term. First, you choose some important path mechanism. For example, LoRa, pure LoRa, adapter prompt, and prefix tuning. Yeah. And another is allow users to specify the sharding policies. What is sharding policies? Is some configurations like FSDP or 0. FSDP is supported by native PyTorch and 0. And if we adopt 0, we need to import DeepSeek. And this is the second one I think is very important. Another is maybe you can support some command optimizers or some learning rate schedulers in the fine-tuning config. And the fourth is maybe we could allow the model quantization, and also maybe some CPU offloading features. By now, Kubeflow training version 1 has implemented a trainer for LLM. If you are interested in it, you can just click this link to see the code here. Yeah, after you take a look at the code, you can see that it's integrated with data and model initialization. Yeah, and this is all separated in the Kubeflow training. You can see this is separate container for storage initializers and the trainer. And it has the limited fine-tuning mechanism support. It's the version 1 haven't support some sharding policy like FSDP and 0 now up to now. So we need to migrate to the version 2 and support more fine-tuning configurations in accordance with the growing needs in custom LLM fine-tuning. And this will allow training operator become a more powerful tool in the fine-tuning. Yeah. In my proposal, I want to use the PyTorch framework to implement as trainer and the torch run as a launcher. Yeah. Next one, I want to discuss about the native PyTorch APIs or Hugging Face transformers. From my perspective views, I prefer Hugging Face transformers because PyTorch APIs have complete control over models data and usage of the compute resources and distributed training configurations. It's a PyTorch, the native PyTorch API is the advantages, and it will allow users to customize their model training with greater flexibility. However, the side effect of flexibility means that we need to implement almost everything on our own, which would be extremely complex. And also, the flexibility means that the configurations we specify is model specific or scenario specific, like FSDP or other 0 configuration. If we don't use the transformers API, and it will lead to a scenario that we need to pass a lot of custom parameters to define the fine-tuning process, which I think is inefficient and conflicts with our original motivation to design a universal and user-friendly LLM trainer. Based on the reasons above, I propose that we should use Hugging Face transformers to implement the LLM trainer, because almost all famous LLMs have its repository in the Hugging Face, and very few companies do the print chain in the current times. And also Hugging Face transformer has rich inbox for features like PEFT in Hugging Face .peft package and FSDP in the accelerate package, and the model quantization in the optimum package. And I think it will greatly ease our workloads in developing and maintaining this trainer and make the trainer a universal trainer. And I will show the design details for you. First, we will implement a fine-tuning config field in the trainer data class. Yeah, I will show you a intuitive side of this job of this API. We will initialize a training client and trigger the train function, and we will specify the data configure. And what's more, this is the trainer. This trainer I specify here. We will implement the fine-tuning config here, and we will specify some configurations like PEF config, like LoRa or sharding config, like FSDP config, and some other maybe optimizer config or quantization config and offloading config. And we will finally reference the training runtime to make these configurations override those defined in the training runtime, or pass them to the environment variables in the training containers. Next will be the specific configurations, which is not completed yet. I have define the LoRa config, like LoRa alpha and LoRa dropout. Yeah, and this will be this, and I think we should also discuss with which configuration we need, because we may not support all the configurations like adapter, prompt, or prefix tuning here. Yeah, this is what we need to talk about, and also some whether to add some features or to delete some features. That's all. Thank you.
Yeah, thanks for sharing. Any questions from the community?
Yeah, I think this is great work. I think we can still discuss about some more parameters that we may need to add. So I wanted to understand, like I'm not fully like into this, but the offloading config, what and all parameters would it have? Like, isn't it like would it be only one parameter, or like what and all types of parameters could it have?
Yeah. That is what what I also want to discuss about. In the Llama recepts, the CPU offloading is specified in the SSDP. And I wonder if we out of other configurations, whether we need to support CPU offloading. Yeah.
Okay. And one more thing, where do you think we should add stuff like batch size and stuff to do with like context size, batch size?
The hyperparameters, right, in IntelliJ?
Yeah. Where?
Like I was asking, like, do you think we should add it somewhere here in one of these comments?
Can you
Yeah, it
make it
should be the way
slower? Yeah.
how users can modify these hyperparameters for the trainer arguments, right? Like,
Okay, right.
How
Okay.
modify the hypermeter? We will pass them in some other configurations in the trainer. Yeah, trainer with support. I remember Andrew have implemented some other yeah.
yeah, so I mean, we can definitely use other, field called maybe
Yeah.
hyperparameter. I know OpenAI in their fine-tuning jobs, they probably use the hyperparameters argument, if I remember correctly.
I see. Okay.
Yeah. And fine for you. This fine-tuning config is only for LLMs, and we can it's specific for LLMs, and we can have also other configurations. I can find them.
Mm-hmm.
Okay.
Find
Yeah,
them.
yeah, that makes sense. Yeah.
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 Yeah, I think this is great. I think my only question and maybe things we need to evaluate, what will be the trade-offs to use accelerate compared to torch run? I know that are fully compatible, right? But if we rely on Hugging Face APIs, do we lose something, right?
It depends on what features we want to implement. If we Hugging Face have a rich score for PEFT and SS and 0, yeah. FSCP can use the native PyTorch API, and we can combine them, not just use Hugging Face informers and other libraries. Yeah, I mean something we can simplify our implementations of this. So such as LoRa and QLoRa, so configuration.
But we can do the same for the PyTorch, isn't it?
Yeah. But it's more complex, I think, and we need to pass more parameters to define this, to define the training process used native PyTorch API. I think it's unnecessary. Also idea.
Yeah, so yeah, good. Yeah, because like when I was experimenting, because like the trainer that we built for this KubeCon, we've used the Llama recipes behind the scenes.
Yeah, I see.
And they're also using the Hugging Face APIs to get the model, right?
Yeah, right.
And they just
Because
yeah, go.
go. It's because transformers have already implemented some and their implementation of path is mature and is more robust and scalable than our implementation is if we implement it with our native PyTorch APIs. I think.
But
What's your strategy?
yeah, I don't think, again, as I said, right, in Llama recipes, like what they do, they also using Hugging Face from pre-trained API. Like
Yeah,
they also attach the model to this from pre-trained, and then they pass
yeah,
this model to FSDP, to the PyTorch FSDP, right?
yeah,
I think so. My only question, if we rely just on Hugging Face, and if we use Accelerate, what we lose, right? Like it doesn't mean we need to implement the entire transformers, entire implementation for every model, right? Because we still can
yeah,
leverage the Hugging Face from pre-trained, right? But we can
yeah,
just bypass this model to the PyTorch APIs to do to define the training loop.
yeah,
And we can also support, like the question, I'm not sure if we can support all the same parameters, like, I think quantization we can support, QLOR as well, like from my, like, initial look on the Llama recipes. I think the question, what we cannot support. Like, for example, can we leverage the same loop, not for Llama, like for Mistral, for example, right? Or for Phi, like Microsoft models, right? So this I haven't got the chance to explore.
yeah,
So what I can do, I can commit my changes to the GitHub, like in terms of what changes I did to the Llama recipes, so you can maybe take a look. And then
yeah,
maybe we can understand like what exactly we should do there, right?
yeah. Do you need to share your screen or
Yeah, I can just give me a second.
yeah.
Meanwhile, I have one question. So
Yeah, wait a minute.
yeah, so like like similar to Hugging Face Transformer, there are similar libraries like OpenAI's Triton and DeepSpeed by Microsoft. So like, should we design something like generic that we can support in future other libraries as well, and not just stick to Hugging Face Transformer?
Yeah, and the question, like, what do you think are benefits to design this generic library to support other frameworks? Like, for example, let me ask you the question: when you feel like there will be a need to use DeepSpeed compared to using the torch run?
Like there can be performance, like some library can have
Mm-hmm.
like some better features for a specific use case.
Mm-hmm. I
So
see.
in general, like different people can use according to the need, that suppose certain library is better for this use case.
Mm-hmm. Mm-hmm. I don't think we can. I mean, we can definitely have more than one trainer, right? We could have a torch trainer, we can have a transformer trainer, we can have, deep speed trainer, right? I don't know if we can. Do you feel like we can design a trainer in a way that they can actually support multiple different frameworks?
Like
Yeah.
the configurations which we are defining, the parameters, like we can have probably, like we can instantiate classes according to the library which we are choosing. Probably now the implementation details that I need to think about, but it was just a thought, like, should we stick just to Hugging Face Transformer?
Yeah, I think that's right. So again, I think we should. So in terms of configurations, I think this should be. So in V1, like what you've done, like you basically bypass the entire training arguments in our SDK. So data scientists can use all those parameters. So then we serialize them to our trainer. I think that the problem with this approach is really hard to. It's not actually so basically users get a lot of errors because of unsynchronized versions of the libraries, right? And other problems what they see when they try to use these different synchronization. So I think the configuration should be driven by us as the community. And I guess probably we should support these configurations on different frameworks, right? Because like from my understanding, those configurations like LoRa, quantization, and other things, they're kind of like abstract from the, or even hyperparameters, right? They abstracted from the framework, right? Because everywhere learning creators exist, right? Everywhere maybe LoRa and rank they exist, right?
Right.
But maybe for some use cases, deep speed will be more performant compared to torch-run. Maybe if you leverage, I don't know, like on-prem clusters, right? Because like we discussed this with Yuki before, but on-prem, people usually do MPI because it's kind of faster compared to torch-run, right? So these things that definitely make sense. I think the question, do we want to unify the configuration, right, across all these frameworks?
That will be pretty difficult, I think.
Yeah, that's right. So I guess like let's maybe brainstorm some ideas on like Xiao's docs. So maybe Deepankar can also add some of your thoughts there. What do you think? And then maybe we can design something which can be future-proof. What do you think?
Yeah, sure.
Xiao, does it look good to you as well? Like maybe we can discuss few alternatives and those topics as well.
Yeah, yeah. I wonder if I understand you correctly. You mean that we need to investigate into what we lose if we adopt transformers accelerate library and any others.
Yeah, so my first question again, if we use accelerate, right, compared to torch-run, what we need to do on the backend side, right? Do we need to support accelerate as the starting point? Because today we don't support it, right? And I don't know like
Yeah.
how, like I'm talking about like the plugin, right? Like the runtime plugin. Do we need to have a plugin for accelerate, right? So then we can propagate appropriate environment variables, right? To those libraries. And also, like again, back to a point around. So let me show you what we've done in our POC in this fine tuning. Give me a second. Yeah, so this is the adopted script, and I will share it with you. But basically, what we do here, right? So we also passing this model to the Hugging Face Llama APIs, right?
Yeah.
And then we using this model to attach to the FSDP, which is actually right here, right?
Yeah.
So we still don't implement the entire like transformer, like like the model implementation, right? So we're still reusing some of the Hugging Face APIs.
It's still using some native PyTorch API. And it seems that this script didn't use functions in Hugging Face except for loading from pre-train.
It does, right? So if you take a look at the model object, it basically using this from pre-trained here, right?
Yeah.
So you're passing the model.
It's only use this. Yeah, it's only use this. You only use this function in Hugging Face transformers.
Yes, yeah, that's correct. Like the only difference is we don't use Hugging Face trainer. We're using basically defining like the PyTorch loop inside this train API here. So here, this is like the entire loop where we basically perform the training, right? And like the question, can we adopt it to support non-llama use cases? Like, can we support it for other models, right?
Yeah.
Mhm. Because I know that like in llama recipes, they also do some changes for dataset. Like if you go to data, right, they have this where is it? Fine tuning. Yeah, datasets, right? Yeah. So they basically have a pre-processing for every dataset, right? So can we somehow, like the question, do we need to also do this in our trainer? Like, because I guess like if you open the alpaca, right, it does some,
Yeah.
pre-processing, like to make sure you can process this, you can pass this data to the fine tuning. So I guess this we should discuss as well, right? Because are we only like the question how we can make this dataset processing abstracted, right?
I
Yeah, go ahead, Francisco.
Yeah, I actually IBM has an open source project called FMS HF built on top of is an open source project that's built on top of the Kubeflow training operator and Hugging Face doing somewhat similar stuff, and they actually have a whole bunch of pre-processing, data processing, and that's actually the bulk of what's in there. It's a big rabbit hole, is what I'll say, and my only 2 cents is like it's fine if you want to put it in there. Obviously, that's kind of at your discretion, Andre. But like it's a lot, and my only concern, to just kind of say candidly, is that it might distract away from kind of KFTO's core, like the training operator's core focus.
Yeah, I think the goal of all of this was to provide the blueprints for folks to fine-tune all this, like fancy LLMs on top of Kubernetes, right? So because like tomorrow, Meta, maybe they will release Llama 3.3. Like we
Yeah.
just provide an API to quickly do the fine-tuning of this model, right? And it doesn't mean we should only like rely on a single, container we're going to build, right? So, and we can, limit ourselves which data set we're planning to support maybe initially, right? So maybe we only support like instruction data sets, right? Which have specific, like formats, right? And we can have this constraint, right? I think the question is like how we can get started, right?
Yeah.
And I guess, yeah, go ahead, Serge.
Sorry. What regarding this, what I think is I agree with Shao in the sense that so if we implement our own PyTorch code or the Torch run code, the problem would be that let's say in the future there are new models where this code might fail. So every time there is some bug, any new model or anything new, then we know that for a fact that transformers, if you upgrade the version, there is most likely it will be fixed with that, right? But we can never guarantee that our script will be working for most of the all the models and all the data sets. And this pre-processing, even I have to look into this, but this pre-processing also would be reduced, I think, if we use the Hugging Face method, Hugging Face library, right? Because everything will be there in their format.
Yeah, that makes sense. And I guess like we need to use the Hugging Face trainer, right, to kick off the loop, right?
Correct.
Mm-hmm.
So even in this, so if you go to finetuning.py, I noticed that so for the FSDP part, if you see, they are actually saying that they're wrapping specifically. One second. They're wrapping specifically one layer of the llama model, and there's not. I think I forgot the line. Wait, let me check. Give me 1 second.
Yeah, but this is the llama model, right? Like where they're wrapping inside FSDP. This is from
Correct. So,
right?
so knowing what, yeah, in line 261. So 261, right? So like we wouldn't know what the best auto wrapping policy would be, right? Like for each model, it might be different. So there will be a lot of caveats, and we might need to do workarounds for certain models. And so I think it's better to rely on one library.
And this wrapping actually perform inside the transformers, right? So they do this, they know like what is the best wrapper for every model, right?
Yeah, I'm guessing. Like, I haven't experimented, but that's my guess.
Yeah, I mean, I would like to, I mean, if you can, explain this pros and cons, like in more details, like what we lose if we rely on the Hugging Face transformers and what we get if we rely on the Torch APIs, right? Directly. So this I would like to understand in more details, right? Yeah, because I agree with you. Yeah, we don't want to duplicate what Transformers is doing, but at the same time, we want to provide enough flexibility so we can leverage all these Torch, advanced Torch techniques, right? Maybe tomorrow they will release a new API, not FSDP, but maybe a more advanced distributed technique, right? We want to make sure we kind of support it in our orchestration.
Makes sense, yeah.
Any other questions from the community? Yeah, I guess then in that case, as the next step, like in Shao, what will be really helpful if you can explore how actually this trainer should be implemented in a way that's, like whether we need to define a new plugin, like to kick off this job using Accelerate, not like Torch Run, because I've never been actually be able to run transformers with FSDP using the training operator. Like, I don't know, like what you need to configure to make sure you can appropriately distribute your model and your data, right? I'm aware of, Torch distribute that are parallel, and it's simple to configure, but I'm not sure how to properly do this on the Hugging Face level, right? Because the problem with this, again, like they do a lot of things behind the scenes, which you cannot control. And yes, it's maybe simple, but at the same time, it's actually just confusing developers and users, right? So maybe it provide us less flexibility on things we want to get, right?
I think I should first investigate into these two different implementations, and and better implement a Hugging Face version of fine-tune script and see what we can use and we can use.
Yeah. And no one's stopping us to create more than one trainer, right? Like we can think about maybe for Llama models we can use Torch trainer, maybe for like for other models we can use Hugging Face trainer, right? I mean, I understand like it's kind of additional burden on us to maintain all those trainers, but I think the question would be like the most performant way of maintaining those abstractions, right?
Yeah, that makes sense.
Yeah, I will let you know once I commit this code to the upstream, so you can also take a look what like specific changes we've done, because the problem that I was facing, I only had V100, and V100 doesn't support the bfloat. So I had to make a lot of changes to make sure this code actually runnable on V100 by just using the float 64 and without any quantization. Because this is another question, right? Like which accelerates, like which type of hardware we're planning to support as a community, right? Because running the code on H100 and running the code on V100 is completely different story, right? So I think these things we also need to discuss sometime.
Yeah, I agree.
And maybe also now a type of accelerator, right? Because I mean, this code actually can be run on Intel, right? On XPU, right?
Yeah. The device.
Yeah, the device actually also.
Yeah. If I remember we have a device. We have resource fields in the trainer config. Do we need to support devices built in the fine-tuning config?
Yeah. Yeah, I think it's and I guess like we need to support those type of runtimes, right? That they can support multiple devices, right?
Yeah.
I would say this is separate. I think first of all, let's just focusing on what initial implementation of trainer we should do, and what type of models we want to support. And again, as I said, like we don't need to support all those 1 million models from Hugging Face, right? Maybe we'll initially support just 3 of them, right? And then slowly see how we can make this more generic to support other models, right?
Yeah.
All right, that makes sense. All right, so we're almost over time. Any last questions, comments on this discussion? Right, I think it was great. Thanks so much, Shao, for starting this. I think it was amazing to to see how we can benefit all those configurations and have initial version, have initial implementation of those trainers. Let's collaborate in your doc. And at the same time, I will also let you know for the once I commit this code to the upstream, so you can take a look on what we've done.
Yeah. Okay.
Right.
And quickly.
Any last questions? All right. Thank you so much then for your time. So see you in 2 weeks. And at the same time, please let me know if you have any other follow-up questions, and we will let you know about the release for 1.9 and 2.0 as well. Right. Thank you guys. So see you soon. See you around.
See you.
Bye.